Hello and welcome back to this channel. Today we are going to study 11th physics. We are starting a new chapter, that is chapter 4, motion in a plane. So in the previous video we have seen every concept related with motion in a straight line. Now we are moving from one dimension to two and three dimensions, right? So now, first of all, what will be our first question, that is what is the need of vectors? In one dimensional motion only two directions are possible. So the directional aspect of the quantities like position, displacement, velocity, acceleration, they can be taken care by using positive and negative sign. So in chapter 3 we dealt with one dimensional aspect, we utilize plus or minus sign. But now as we move ahead we have to deal with things which are in two or three dimensions. Two dimension is known as plane and three dimension is known as space. So objects can move in large number of direction as compared to one dimension. Hence, to describe such motion we need to introduce the concept of new physical quantities which are called vectors, in which we will take care of both magnitude and direction. You see over here below I have given two sample figures of three dimension, right? Here there is a point which can be represented by three coordinates, that is why we can say it is in three dimensions, right? X coordinate, y coordinate and z coordinate. Clear? Now let us see how to represent a vector. We all know that vector quantities are those quantities which require magnitude as well as direction. We have all learned when we have learned about scalar and vector, right? So vector quantities need both magnitude as well as direction. For example, velocity needs direction as well as value, force, displacement, etc. But now how to write the vector? So the vector is represented by putting an arrow on the symbol of that physical quantity, or if you don't want to write the arrow you can also represent that vector as bold letters, right? You can see force vector, we have a physical quantity called force. Force vector can be represented by F and then vector, the arrow symbol over here you can see. And if you don't want the arrow symbol, only but in bold letter. But while we write in the notebook, bold letters won't be easily possible, so it will be better to use the arrow sign. Now the value of the vector quantity is shown by putting the symbol inside the modulus, the vertical bars in which, so the same force vector can be represented as putting the mode over here, or just the symbol will also determine the value. Note that the vector quantities will obey all specific laws of combination. Which laws of combination? Mathematical laws of combination. Now how to draw the vectors? We have seen the representation, but how to draw the vectors? Now to represent the vector quantity geometrically, an arrow is drawn. So arrow will contain tail and head. So arrow is drawn such that the length of the arrow will be equal to the value of this vector quantity on a proper scale. Okay, remember this word scale. So we have to choose, we have to form a proper scale, then only we can convert the value to the length. Okay, the head of the arrow is put in the direction in which the effect of the vector quantity is prevailing, as we will deal with magnitude and direction both. So we need to put the head of the arrow in specific direction. Now this arrow can be drawn from any point, so that is why it is known as free vectors. In future we will also see that vectors must be drawn from a specific point. So right now whatever we will see will be of free vector. Now let us take an example that we will be drawing a velocity vector and it is towards the east and the magnitude is 40 km per hour. So magnitude as well as direction we have. Now for your convenience I have shown the figure of the directions east, north, south and west. So let us first decide the scale. Okay, 1 centimeter will be equal to 10 km per hour. 1 centimeter is representing 10 km per hour. So for 40 km per hour, how much we need? We will need to draw 4 centimeter. Now exactly 4 centimeter it was not possible, so I have drawn some markings, right? So we will start from here, 1 centimeter, 2 centimeter, 3 centimeter and 4 centimeter. You can see the head part and the tail part, and specifically I have drawn this towards east, right? So this vector is representing a velocity vector whose value is 40 km per hour. So this is how we will represent the vector geometrically, always taking care of the direction as well as the magnitude, but magnitude will be according to the scale. For example, if I say that a car is moving at a speed of 400 km per hour, so in that case from this scale we need 40 centimeters. So what we will do, we will choose another proper scale. Now two things, let us start: position vectors and displacement vector. This was necessary as you will understand that they are special type of vectors, and these vectors will be mostly utilized in future chapters. So now representing every vector will need a reference point. So here for this figure we have chosen our origin as the reference point. So this is x-axis, this is y-axis, and both are coinciding at a point called origin. Suppose a curve is drawn to show motion of any object in xy plane. So let us assume that this black curved line is a line which is representing that the object was in motion from here to here. Clear? Now we will select two instants of time t1 and t2 when the object is exactly at point A and B respectively. So this is simply like at time t1 the object was at point A and then it happened to go by this direction, and at time t2 the object was at point B. Okay. Now very important, position vector. So we can say that exactly at this point at A, the object was there at time t1. So how far was it from the origin, from our reference point? So that will be nothing but our position vector. So always start from origin till the exact point. So this red line, this red arrow is representing R1, and that is nothing but position vector of object at point t1, at point A at time t1. Same way R2 will be position vector of object at time t2, which is at B. Clear? So R1 and R2 are our position vector. Now position vector must start from origin till the point which we are finding. And now pay attention to the green arrow. What does this mean? This is joining the heads of two position vectors. So in short, from A to B we have drawn a line which is straight line which determines the shortest distance. And what was that shortest distance called? It was called the displacement. So this AB vector is nothing but displacement vector. Okay. So here position R1, R2, and the difference of position will be shown by displacement vector AB. Clear? Now, at the end of this video, let us discuss the types of vectors. There are many types of vectors, out of which few I have mentioned over here and also tried to show that in the diagram. Equal vectors. Values and directions of two vectors are equal, then they are called equal vectors. You can see over here, both the vectors are having same direction and same value, that means same length, so they are called equal vectors. Parallel vectors, vectors with same direction but not necessary that they are the values are same. So here you can see they are moving in same direction but the length are different, right? So they are called parallel vectors. Anti-parallel vectors. Vectors which are in opposite direction are called anti-parallel vector, but they must be parallel. So that is why in the name parallel is there, but anti means opposite. So here you can see they are in the opposite direction, but they are parallel. Negative vector. This one is important. Vector with equal value but in opposite direction. So you can see over here there is a vector who is going in separate direction and exactly the same length another vector is there but that is going in exactly opposite direction. Collinear vectors, vectors which are in same direction. So over here you can see two vectors, same line, same direction. Okay, so they are collinear vectors. Coplanar vectors, any two vectors which are in a plane are called coplanar vectors. You can see any example that you take, they are in same plane, so they are coplanar vectors. So I haven't drawn anything specific. And lastly, co-initial vectors, vectors with same initial point. So over here you can see there are two vectors whose point of origin is common, so they are called co-initial vectors, right? So in the next videos we will see, or we will continue this type of vector, as we still have few types of vectors left. So that's it for today. Revise well, watch the video carefully. Thank you.